Hello and welcome to our breakout room number 2. I hope you enjoyed the morning session, and I also hope that you will enjoy the presentations we now have prepared for you. My name is Gerhard and I have the pleasure to guide you now through this session. We will have 18 speakers who will present their projects and give updates and insight into their activities, and all of them, they are about an important topic around green manufacturing, circular economy, waste reduction. One organizational thing, if you have questions to our speakers, please put them into the chat, and depending on the time after the presentations, we will put them on screen and go through them. With that, I would jump now already to the first project. It is a maestris, and it will be presented by Julia from Aalto University.
Yeah, thank you, Gerhard. Will you open my fact sheet, or is it already? It's already there, I guess.
It's already there.
Okay, thank you so much. Yeah, so welcome everybody to my short presentation. I'm Julia Anna Weber. I'm actually not from Aalto University. I'm from Technical University of Wien in Austria. But in fact, this project, the maestris, is led by Roy Björkstrand, who is from Aalto University. And I'm very happy to be here today to tell you some words about what we do. So what problem are we focusing on? So additive manufacturing is in every mouth at the moment, and I think it brings us great benefits for flexibility and competitiveness for European companies. But in fact, the change is quite slow. So we try to bring additive manufacturing and knowledge in these companies who are interested in this. Project maestris already started 1 year ago with Imagine. And this, so this is a continuation of this project, and we already started to find out where the knowledge gaps are in Austria and Finland. So we had a lot of interviews with people from industry and found out what are the problems, why can't they use this technology? Why is the change so slow by them? So, and we had already workshops in these countries. And this year, starting 2022, we have 2 new partners from Lithuania and the Czech Republic. And now we try to expand our knowledge from the first year to these countries. And we already had some workshops there. We had already 40 professionals educated in 22. So one more point which is important for us is that our idea is to make the European companies more competitiveness, because with additive manufacturing you can, for example, design products which would not be possible with other technologies. So we can have a look on raw material use and more efficient energy use. Yeah, so with all our partners, we are very happy to improve the knowledge of these people, and we thank EIT that they support us to have this great opportunity. And we thank all of our project partners. Yeah, this is already everything from my side. Thanks for your attention.
Thank you, Julia, and we thank you that you did this project and that you continued with it for the second year.
Yeah, that's really great.
Thank you. So let's go to the next one. This will be Silvia from the University College Dublin with the project AM Healthy Future 2.
Thank you very much. It's great to be here. So this project is a continuation. We started it in 2021, running it this year, and we'll be running it next year also. It is a partnership between ourselves in University College Dublin in Ireland, Stryker, a global medical device company also based in Ireland, Arts et Métiers Institute of Technology in Paris, France, and the University of Tartu in Estonia. So this is a project that's all about 3D printing in the classroom and bringing those manufacturing skills into the classroom for the next generation. So we're focused on the primary school level, which is young children from age maybe 8 to 11. So in order for this project to really have impact and scale, we decided to focus on the teachers of these children, because teachers, as you know, are very important. They're key influencers in the lives of young people. And if you upskill a teacher, you're upskilling them that they will have an influence and an impact on so many children who will pass through their classrooms over the years. So that's why we're hoping this project is going to have a medium to long-term impact. So we're actually changing the behavior and the attitudes and skills of teachers who then pass this on to their young pupils. So in 2022, we have upskilled 50 primary school teachers at a minimum in Ireland, in France, and in Estonia. And we have challenged the pupils of these teachers, that's more than 2,200 primary school children. They're involved in a 3D design and print challenge with a theme of sustainability. So they're busy doing these projects and making videos of them at the moment. We'll be getting seeing all of their entries in a couple of weeks' time. So we're really looking forward to seeing that. A key part of the project also, and that wouldn't be possible without funding from EIT Manufacturing, is that we've been able to install 3D printers into classrooms. So that is very important. It's a piece of technology and hardware that's actually now in the classroom, which means it has a home there. It's more likely to be used if it's there. And very importantly, then we are also supporting those teachers on an ongoing basis from a technical point of view, because if there's a problem, they know they can come to us and they will get support. And in that way, also, they're more likely to continue on with the project, and they don't feel like they are on their own. So all of this is trying to instill those 21st century skills into the next generation. That's collaboration, creativity, critical thinking, and communication skills. And we've had great feedback from year one in the project. The teachers very enthused about it and very, very excited about the project. And this year is looking very good as well. So that is all from me. And thank you very much for your time. Happy to answer any questions later on my project.
Thank you, Silvia. Having a daughter in school, I'm convinced that they will be happy to have such a topic in school. I'm very convinced about that. Thank you. So going to the next project, Assister, the lead partner there is LMS, and Elias from LMS will present it.
Hello to everyone. My name is Elias Papadopoulos, and I am a research assistant at the Laboratory of Manufacturing Systems and Automation from University of Patras. Today, I will communicate to you the Assister project, an idea that provides awareness to health and safety managers about the environmental conditions which their personnel are working. Manufacturing is a complex process with high probability of health and safety risks for the involved business roles. Manufacturers' experience shows that the environmental conditions of the production area strongly affect human performance. Ensuring occupational health and safety for employees, contractors, end users, and neighbors to the operation has become a public priority in industrialized countries and the primary concern for the manufacturing industry. Exposure to dust, toxic and allergic substances, high temperatures and high decibels can be defined as hazards to human health, while environmental conditions of the production area strongly affect human performance. Until very recently, monitoring of the environmental condition in manufacturing workplaces has been limited due to high cost and management complexity of sensing devices. Introducing IIoT for capturing environmental data enables a whole new level of visibility into daily operations. A sister project developed an industrial Internet of Things solution, improving the industrial environment with real-time monitoring of the operation environment conditions, a tool that offers edge device for data acquisition, integrating different types of sensors, a cloud platform enabling data processing, and data analytics for conditions evaluation and prediction. The solution will eliminate the need for manual and physical check of factory floor conditions, ensuring employees' comfort and bring performance benefits to manufacturing. Thanks the EIT Manufacturing that gave us the opportunity to build this innovative idea into a product. Thank you for your attention.
Thank you, Elias, for presenting Assista. It's quite a huge scope you have to cover in this project.
Thanks a lot, Gerald.
So the next project is from Annalisa from EIT Raw Materials, and it is the project Circular Economy.
Thank you. Let me then continue with introducing the EIT community circular economy. My short presentation is divided into two main sections. First, I will be introducing the community as such, and then I will be giving an overview of the variety of activities we have had this year. So I will begin by filling you in on the background of the Circular Economy Initiative. The European Institute of Innovation and Technology and its Knowledge and Innovation Communities, or EIT KICs, have initiated altogether 4 strategic synergies activities. Circular economy collaboration is one of those activities. For a coordinated and joint approach in circular economy as an EU policy area, the community brings together EIT Raw Materials, EIT Climate KIC, EIT Food, EIT Manufacturing, and EIT Urban Mobility. And the objective we have then is to transition towards circular economy, as well as to ensure the implementation of the circular economy strategy and action plan on a local, regional, as well as the EU level. The challenge that we all know we have is that we need to make much more informed decisions and transition from a conventional linear economic model into a more circular one. That is, if we are to accept that the living world cyclical model works, how can we change our way of thinking and acting so that we too would operate the circular economy? Over the past year, we have responded to these challenges with 4 different types of activities, which I will now be also briefly introducing. To begin with, we have the Environmental Technology Verification Support Scheme. The scheme takes companies and their technology through a third-party validation, which assesses the performance using international standards. EIT Circular Economy Community has supported 5 scale-ups to go through the scheme and help them gain credibility and, as a result, access to new markets and investment. As a circular economy community, we also aim to identify and support startup scale-ups and SMEs with significant new solutions around circular economy. This year, we looked for solutions in the areas of new circular business models, circular economy assessment methodologies, waste valorization, and digital product passports. One company from each of these categories have only recently secured financial awards to boost their product, service, or technology and become part of the circular economy network of the European Institute of Innovation and Technology. We also regularly organise EU Circular Talks, which is part of the EU Circular Economy Stakeholder Platform. And as such also serves as an opportunity for all those interested in circularity and circular economy to learn, interact and discuss on these topics. And finally, for the purposes of better understanding where the possible synergies lie in terms of circular economy related activities in the EU, we have concluded 2 systems maps that give an overview of all the circular economy related stakeholders, as well as their strategic plans, roadmaps and position papers, programs and projects, including funding opportunities and tenders that they offer. That's all about the circular economy community. In a few weeks' time, on the 1st of December, we will have an online Future is Circular event, where we'll be also introducing our activities for 2023. And I very much hope that at least some of you would be able to join us over there as well. Thank you.
Thank you, Annalisa. It's great to see that the different kicks of EIT work together, that they join their forces to work on such a topic. The next project, it's about the condition monitoring system for metalworking fluids. Will be presented by Lena from RISE.
Yes, thank you very much. In collaboration with RISE, the Swedish Institute for Research, and partners from Italy and Sweden, we have developed this sensor. So the market of metal cleaning fluids is growing at a rate of 2% to 4% a year. So it's an increasing market, and it's a lot of dangerous and corrosive chemicals out there. Currently, the way of handling, because it's a sensitive to any perturbation, so you have to have certain concentrations, and everything has to be very specific for things to work. So currently how it happens is that you have a physical person who comes, takes a sample, sends it to the laboratory, they send back a result, and if it's within norm, you continue, otherwise you have to add certain chemicals. So there is several problems with that. First of all, of course, you can't do that very frequently, which means that you have to do it only once in a while, and that results in the concentrations not being optimal during certain periods of time. And the second part of it is that these chemicals are toxic, so humans working with them are exposed, even though they wear protection when they are collecting the samples. So in this project, our solution to this was to work with a technology that we have developed based on measuring impedance that allows you to understand what concentrations you have in your liquids. And based on that, you can deduce how the different components of the liquids have changed, and you can add what is necessary. Based on this, we have, thanks to, so we had this prototype, but thanks to the support of EIT, we were able to build it into a full-fledged product where you combine several sensors and measurement from these sensors in order to be able to continuously monitor the concentration of different fluids in the cleaning tank. And you do this by sending data to a server, cloud-based, and comparing the data that you receive with a machine learning model that helps you understand how to interpret this data. And then once you do that, you get back the results in a form that is readable to an operator. So the dashboard that you can see here on the picture, and the other picture represents the box, how it looks from the inside with all the different sensors. And then you're able to know what kind of substances you need to add to the tank, if any. So this will reduce the need of human operator interaction with the liquids, but it will also allow to have a longer life cycle for the cleaning liquids, because predictive maintenance can extend their life from 2 to 4 times. And this means that it will reduce waste, because we use less chemicals, and less chemicals are in circulation in the process. Right now, we have 2 field tests ongoing, one in Sweden and one in Italy, so that we can then have a marketable and commercializable solution at the end of the year. And we thank EIT for the support in doing this. That's all from my side.
Thank you, Lena, for the update on this very interesting project. So the next project we will have now is from Javier from FIAP about the project Digiman.
Sorry, I was muted. Yes, thank you for the opportunity. Yes, my name is Javier Mendivil. I am from Tecnalia. I'm representing the Digiman Consortium, which is composed by 4 educational institutions: University of Porto, FEU, Grenoble INP, Politecnico de Milano, and University of Tartu. And then we have Intexcentras from Lithuania, a smart manufacturing services center, and Tecnalia, where I work, which is an applied research center. So yeah, this the Digiman project. Okay, the problem that we address is the need of upgrading and upskilling of the knowledge of workers in the manufacturing industries to implement advanced technologies and Industry 4.0 technologies. This is the main problem that we address, and the solution is a course that we have developed during 2021 and 2022. It's a 2-semester course combining high-tech contents and skills with what we call transversal skills, such as innovation skills, leadership, customer orientation, team working, entrepreneurship, and also combining asynchronous courses with synchronous classes. Why is important this solution and this addressing this problem? We think that upskilling and reskilling of the workforce in the manufacturing industry is the key to implement these technologies, and it's very important also to develop what, as I said before, what we call this T-shaped workforce, T-shaped workers that are able to get good knowledge in technical domains, and also other general knowledge and skills in the way to implement the technological knowledge. The results of the project. Okay, we have created several, along the 2 semesters, several courses, modules, 5 modules per semester, and the modules, they have learning paths, different learning paths regarding these technological domains like cyber physical systems, Internet of Things, data analytics, machine learning, robotics, human-robot collaboration, and then also some transversal domains, as I said before, innovation, entrepreneurship, customer orientation, team working, and so on. So yeah, these learning paths are still well available in SkillsMove platform, and they will be available for any participants that could be interested until the end of the year. And some insights about this. I would say that it's important the methodologies that we have used in these transversal modules. It's a combination with real problem-based learning, community learning, learning with peers, and the use also of some methods as coaching sessions, lean startup methodologies, ideation, and agile teamwork. And well, this is all. I will be happy to answer questions if you want. Thank you very much.
Thank you, Javier. I guess your project touches very important points with the upskilling of the workforce in manufacturing. So thanks for that. The next project is Green APS by Luis from Inestec.
Yes.
Hello.
Good morning all. My name is Luis. I work at the major R&D institute at Portugal, which is called Inestec. we are working in a consortium which involves University of Modena and Reggio Emilia, two software companies, one which is the developer of, among other things, an advanced planning and scheduling solution, which is Softinov, and Varit, which uses AI for industrial projects. We have two pilots, RP Santini and Voestalpine. RP Santini produces metal parts, small metal parts with high added value, and Voestalpine is a very large company in Austria, which produces, and other parts in the world, which produces critical parts for instance, for planes, such as landing gears, etc. It's a heavy metal industry, which is a high. One of them, Voestalpine, is an intensive energy consumer. RP Santini works with machines such as multi-spindle machines and CNC machines, is another type of problem. So what problem are we addressing? Industrial companies normally have lots of machines, and energy efficiency comes from acquiring more modern and efficient, machines. But most of the times at industries, we have a mix of older and newer machines, and we have to use all of them to answer, to respond to customer orders, which have increased in number and decreased in the quantity ordered. So we have a problem. The other problem is that energy prices have reached sky-high prices, and at the same time, we have companies have invested in renewable energy sources. So how do we come up with solutions on how to allocate production orders to the machines we have, which are of different generations, and how do we sequence the production orders on those machines so that we fulfill the delivery dates that were demanded by the customers, and at the same time, we reduce the cost of producing those parts. So what is our solution? We are combining a multi-objective advanced planning and scheduling system with an AI approach in which we study the characteristics of the products, the processes, and the machines so that we can identify which are the parameters that influence energy consumption. Using this information, we are going to infer knowledge that is going to be used on an optimization model that uses this information to come up with an optimized solution of allocation and sequencing the production orders on the machines that both fulfill delivery orders on time and minimize the cost of the solution. Okay, this is then finally used by the advanced planning and scheduling system in a multi-objective approach to introduce other processes and to be able to come up with a solution that is then approved for production. So why is this important for society? Because we are going to use less energy to produce the same number of parts, or we are going to produce more parts with the same energy, and we are going to allow companies to be more competitive, which is very important, and also to use energy efficiently, okay, more efficiently. So the main results, we already have a prototype of the AI system installed in the two companies. We are on the final stages of developing the optimization engine. We have the integrations already designed and being placed and being implemented. And we hope that by the end of the project, we'll have the proof of concept for these two kind of companies. So this is why the project is very important and we are excited about it. Thank you all.
Thank you, Luis. Energy saving is definitely very important at the moment. So thanks for the update on that project. The next project is now Green MA, and it will be presented by Ata from Tartu University.
Hi, and thank you, and happy to be here and share our case. I'm actually working at Build It, a Latvian Estonian VC fund, though I am accompanied here by Aivar Pere, who is the entrepreneurship advisor and the lead of this project, who happens to be from University of Tartu. Yeah, so this year, together with 4 other partnering institutions, we set up a EIT Green Manufacturing Accelerator. That's why the Green MA. And we're aiming to help identifying and developing innovative green manufacturing solutions in Europe to help bringing the circular economy and Industry 5.0 vision into life. Also linked with the concept of impact investing in the background. So Greenema addresses the key challenges for early stage entrepreneurs related to know-how, to financing, and also bringing in contacts with the EIT network and the wider manufacturing ecosystem. So this year, we already carried out our first round of acceleration, batch 1, and we are in the midst of our second round. Both include a 3-month acceleration phase, which includes intense mentoring, workshops, one-to-one trainings, and advice in whichever form we can bring it to the teams. And after that, best performing companies, the most promising companies, receive additional support in their implementation phase. So for the next 6 months after the graduation from the accelerator, they receive continued mentoring via the twinning arrangement. Also, after testing and validating the Green Manufacturing Accelerator concept, the next stage foresees creating a dedicated impact fund, impact investment fund, in line with the principles of EIT Manufacturing financial sustainability. In terms of numbers, so counting both batches, we have 35 participating teams from 12 European Union countries. We received 100+ applications. We had quite a challenge to select the best ones. We've held 40+ workshops and roughly 300 one-to-one mentoring sessions to date, both metrics still counting. And also another proud fact, the first demo day in Estonia gathered 100+ investors in the audience, and the second one will be held in Riga in December 7th. So in case you are willing to see what great green manufacturing startups are there, you're welcome to join us. And capital raising is a great metric, and our first batch graduates have already raised more than €1 million. They graduated in August, so it gives us 3 months and quite a good sum of money, and we know that there are still more to come. And last but not least, we also would like to highlight the sustainability assessment tool. So when there's only an idea, prototype, or the very first steps made into the market, there is not much data to report or analyze. Thus, with this particular tool, we nudge our startups from day one to plan their production process and operations in a sustainable manner, as well as to gather data from day one. And this is it from my side. We're super grateful to EIT Manufacturing for their support and cooperation, and happy to answer any questions when the time comes.
Thank you, Ada. Impressive the work you have already done, and all the best for the things which are still coming to your topic. So the next project, it's Learn for Zero. It will be presented by Andrea from Subsea.
Hi everyone, thank you for the invitation. I'm Andrea Barney. I'm a senior researcher at the University of Applied Science of Southern Switzerland, and together with other 4 partners, basically VTT, Technelia, Inegi, and Reply, we have been dealing with this project that is basically inside the education area, and it provides contents for industrial parties to keep up with sustainability and digitalization. We started from the consideration that nowadays, in order to achieve sustainable production, we have digitalization as a main enabler to it. That is something that really can give a boost to the introduction of companies in a sustainable domain. So this project basically worked in that direction, delivering a full learning path dedicated to 4 main topics that are innovation and change management, industrial sustainability, circular economy, and of course digitalization that is on the base of that. So we try to give the learners that are coming from industry the main concepts and the background that can help them introduce these concepts within within their companies. The results of this project are basically, as said, a comprehensive learning course covering all these elements that I say that are then organized in different learning paths that can be selected according with which is the actual need of the learner. So are modular and can be taken according with the actual needs of the learner. We delivered more than 150 nuggets that are those that are composing these paths. So this can be taken, of course, online at home or at work. And so it's quite flexible and very. The idea was to try to construct this system around the actual needs of the learners. I take the occasion to say that we are now really in the moment where we are starting testing these contents. The contents are available, and for people that will join up the end of the year, the contents are still free and under testing. So I also take the occasion for any person that would be interested in join these learning modules to contact me. You can see my email is andrea.barney@supsi.ch, and we are very happy to involve you inside these learning paths. Thank you. I'm available for questions, of course, later on.
Thank you, Andrea, for presenting this interesting project, and to your team for doing this project with us. The next project, NEP, is again presented by Annalisa from EIT Manufacturing.
Thank you. Let me then continue with introducing the EIT community NEP. My short presentation is again divided into 2 main sections. First, I will be introducing the NEP community, and then I will give an overview of the variety of activities that we have had this year. Let me begin by explaining what exactly is EIT Community New European Powerhouse, or in short, the NEP. NEP is part of EU's sustainability-driven recovery plan, and the objective of NEP is to deliver the European Green Deal, a set of policies to make Europe greener and more resilient. For a joint approach in NEP as a EU policy area, the community brings together European Institute of Innovation and Technology and its knowledge and innovation communities, or EIT KICs, as an enabling NEP ecosystem. Important to note here, though, is that NEP is not just an environmental or economic initiative, but it has a design-led agenda, and it aims to inspire us to deliver design-led solutions in response to some of the most pressing economic, social, and environmental challenges that we are facing today. To be able to truly contribute to a fairer society and more sustainable forms of living, EIT Community NEP tries to identify and support social impact startups, scale-ups, and higher education institutions, students, and spin-offs, as well as communities, citizens, and public decision makers, many of whom then also often converge and give rise to wider social changes as a result. As for the EIT Community NEP activities this year, we have supported 20 social impact startups who have received business acceleration services worth 50k each to be able to drive sustainable change. The booster call under which these startups were supported and we also aim to launch again December this year had altogether 1,029 applications from 37 different countries, which also makes it one of the most successful calls within the EIT community. In that each of the NEP challenges is a vast EU-wide social problem, the solution to which cannot be found in traditional economic models nor in top-down initiatives. We are also continuously organizing NEP hackathons, where citizens and the community have the opportunity to radically redefine and redesign the way they live and also their ideas of well-being. Additionally, this year, we also offered seed funding as part of NEP ideation call for ideas of social innovation that would enhance the society's capacity to act. In practical terms, then, the booster call, the hackathons, as well as the ideation call have all proven to lead to viable ways of dealing with NEP challenges, and social innovation usually happens if there are both the need and the will to do something about it. Finally, we also see ourselves as advocates of human-centered methods for creative problem solving and innovation. We are currently preparing 4 different online courses on how to combine analytical tools of systems thinking with the creative methods of human-centric design. This is all that I wanted to say about the EIT community NEP. Thank you all for listening, and if you have any questions, I'd be happy to answer them in the Q&A session. Thank you.
Thanks a lot, Annalisa, for presenting your project. Now we will go to the project with the name Scene, which is presented by Patrick De Luca.
Yes, good afternoon, everybody. So the project has been done with 3 academic partners, Arts et Métiers in France, Mondragon University in Spain, and CTU in Czech Republic. And it covers 2 main technologies. It covers the first technology, it is the virtual manufacturing. So virtual manufacturing, what it is the simulation of the manufacturing based on the physics of the materials and their transformation during manufacturing.
Sorry to interrupt, Patrick. I guess your camera is switched off.
Yeah, I have some issue, I'm sorry.
Thank you.
So, yes, based on physics modeling, not based on kinematics or trajectories. And this is relatively new. And second technology is the lightweighting of structures, which is key in saving energy. So 2 technologies, virtual manufacturing, which is not widespread and that needs tutorials, and the lightweighting, which is always under development. So we developed 71 nuggets. They cover 4 different manufacturing processes: hot stamping, composite manufacturing, casting, and additive manufacturing. And here, why is this important for the society? It comes as a support to the current Industry 4.0 transformation. So what we did in this project with these nuggets is not mathematics or physics course. It is really to support the training of new workers in manufacturing in the current transformation of the manufacturing industry. And in fact, you will see that there are not so many, very few training of this kind in Europe, but in the world actually. So the main result of the project, it is that these tutorials are available on the skills.move platform, where you can access them. And I just would like to add a comment. It is about the use of virtual manufacturing because of 2D transformation and use of data, use of sensors. industry tends to jump on this new artificial intelligence linked stuff. And I think it would be good to keep the link with virtual manufacturing simply because it can work together. So don't replace one technology by another one, but use the best of two to move forward. This is what I wanted to say about the SIN project and the 71 nuggets. Thank you very much. Open to questions, of course.
And I guess this is a very good approach, what you just mentioned. So thank you, Patrick, for presenting the project SIN. The next one is the project Tech to Market, and it will be presented by Christina from Tech.
Hi, everybody. Thank you, EIT, and thank you for having me this invitation. I'm the project manager of the Tech to Market, and I'm representing Tech, which is just one of the 6 members of this consortium, the Institute for Systems and Computer Engineering, Technology and Science. The other members are Building Global Innovators, MADE in Italy, Clean Tech in Bulgaria, Build It Global Acceleration of Things in Estonia, and I salute Arthur from here, which I am glad to see again, and PIAP in Poland. And we all together had the problem addressed of having boosted the need of boosting the entrepreneurial skills into projects that are sometimes don't see the daylight because they are forgotten, because sometimes the European projects end and they don't have the second opportunity because the financing ends as well, and they don't have the opportunity, as I was saying, to leverage their TRL, the technology readiness level, and also they don't have the means and the skills and the expertise to do so. So in a mindset of testing before invest, we try to tackle, first organize a scheme of acceleration phase in 2 phases that could be addressing the 4 flagships of EIT Manufacturing, which is a flexible production system for competitive manufacturing, the low environmental footprint systems, and circular economy for green manufacturing, digital and collaborative solutions for innovative manufacturing ecosystems, and human-machine co-working for socially sustainable manufacturing. All these flagships have different challenges, and we could not select just one of them, meaning that all of them are important and all of them could bring innovative solutions, and they are innovative solutions in hands of entrepreneurial teams and some companies that need to have an effort or some kind of help to have these projects in an acceleration phase. So Tech to Market has a hands-on program to give that help, meaning that it complies mentoring, training, piloting, testing before investing, because we also have the investment part, not only for the ones that win the competition and win the grants of the competition, but to the ones that are presented to the investors and they are willing to have their leverage in terms of investment directly to the investors. So it's the process of transferring transferring the deep tech technology and R&D to the market in terms of the manufacturing industry. And we tried to select the best in class to the competition, and the competition was very, very keen. We had in July the first acceleration phase, and we select at least 55 projects in the competition, but only 10 were moving to have the grant, but 14 of them were very, very good. So we extend the grant financing to 14. So we had a second acceleration phase now that comprises a second bootcamp, online workshops and weekly trainings, and also some nuggets that accompanying all the companies that entered the first acceleration phase, meaning that we have a circular approach, let's say, to all the projects. We don't forget no one is left behind. We don't look only to the 10 that are only receiving grants and mentorship. We look at all the projects that enters the program, and they have to fill the not only the part that explains how to get to a second and better stage, but we accompany the mentorship, the mentorship, the milestones they propose to follow, and we do it in weekly basis. So the workshops are focused in sustainability and artificial intelligence. Others are for tools for digitalization. Others workshops are for entrepreneurship in sustainability. Others are focused in sustainable finance and green finance. Other are holistic thinking and climate actions. Other teams are the green challenges in startups. Others are focusing crowdfunding platform. And one-to-one meetings are also made in weekly basis between the mentors and the mentees. And what is important for society, that we are training a new generations of mentors, because we were recovering a testing and a world-leading innovation validation methodology from MIT, and we train the trainer and make the trainers available to collaborate with the mentees, and the experts are now engaged with the entrepreneurs and able to convert their technical knowledge into applied value in the market. And also this project aims to make a Europe more competitive market in terms of a cleaner, more sustainable and resilient manufacturing in the industry. Also, we aim to give more job creation and success stories to EIT in terms of what is the next day of these endeavors. So there are at least 10 new startups that are being created. They are going to be followed not only in the end of this project that ends in the December, but over the 6 months after the project ends, in terms of monitoring their milestones and help them out in the first steps in their entrepreneurial steps. So we are very glad and we are grateful to EIT, so we can help these endeavors to become true in these 4 flagships. Thank you so much.
Thank you, Christina. This is a very important initiative to have finally then successful products and projects on the market.
Thank you.
So the next project is DRAM, and it will be presented by Alvaro from Tartu University.
Hello, everyone. My name is Alvo, and I'm from the University of Tartu, and I present today the project called Training on Multiscale Modeling Simulations for Additive Manufacturing. The project was carried out together with Technical University of Vienna and ESI Group. So we addressed the problem that many manufacturing companies and engineering offices are entering into additive manufacturing area, simply said 3D printing. And the integration of digital 3D printing simulation in process of design is a very challenging part in implementation. So to succeed in implementation of simulations, it's necessary to build up knowledge in digital multiscale modeling. And if we talk about multiscale modeling, we mainly talk about finite element method. And training of actual design professionals and future professionals, engineers in universities necessary to fill the existing knowledge gap. During the project, we first evaluate the knowledge gap of companies who wanted to implement additive manufacturing. And next, we made tailored training packages in additive manufacturing and multi-scale modeling to fill up that gap. A set of nudgets we prepared had basically 4 main learning paths. First was, of course, introductions called process and simulations basics. The second set was called design optimization. So modeling of design to make it ready for 3D printing. Third one was called process parameter simulation. It's about the moment of fabrication simulations. And the fourth one was called distortion simulation. So it's basically stress analyze, looking from engineering point of view. We gave several test courses, and what we learned from that, but people from university generally have much higher expectations, but people from companies are very subject oriented. They want to do specific things, and they are much more focused on learning. On the other hand, which was also a little bit expected, that people actually prefer hands-on trainings. And that's the reason we have a next hands-on training in QEV I think it's beginning of December. So you are all welcome to register and come. I guess there's few seats still available. And that's it from my side. Thank you.
Thank you, Arvo, for the presentation of your project. And it's good to know that there are places available. So the next project has the name Epsilon ML3 Epsilon ML, and Marco will present it and bring light into this cryptical name. Thank you.
Yeah, thank you. Good afternoon, everyone. Thank you for this opportunity to be here today. I'm Marco Spaltini, PhD candidate at the Manufacturing Group of the School of Management of Politecnico di Milano. Today, I'm here to present the YML project. YML stands for Young Manufacturing Leaders. It is a project coordinated by Politecnico di Milano, indeed, together with the World Manufacturing Foundation, University of Prague, University of Braunschweig, the EML, Chalmers University, the University of Porto, the Istituto Macchina e Herramienta, IMH, and the University College of Dublin. As we all know, manufacturing industry is facing many challenges whose effects were also exacerbated during these last years. Among them, for sure, skill gap and lack of competencies are threatening the most the competitiveness of the European manufacturing industry, at least in the medium long term. So the YML project was launched now 3 years ago, exactly to tackle this issue. More specifically, it is a network of students, university students, and young professionals who share their interest toward the manufacturing industry and all the also the related topics that has been already well presented by the colleagues so far. So the network was born to reach 4 main goals, which are summarized in the slide that you can see, which are the spreading awareness of digital, sustainable, and inclusive manufacturing. So we're tackling concept of digital technologies and also sustainability issues, developing the right skills needed for the future of manufacturing, connecting young people all around the world with key players in the manufacturing industries and reach out some new opportunities, and empowering students and young professionals to become the change maker and the leaders of the future. So today the network counts more than 500 members worldwide. The majority are in Europe, but we also have members in the US, in India, in Africa, in Mexico, and in other countries. We are organized in eight city hubs, which are hosted by the partners. And every year we are somehow occupied with several activities. You can see these here. We produced some learning paths two, especially one on creativity, innovation, and entrepreneurship, and also on equality, diversity, and inclusion. That's stressing the double and twofold soul of the networks, one for specifically addressing the manufacturing industry, and one the other addressing the social and environmental issues that are somehow related to the industry. We also launched two international contexts who's participated many YMLs worldwide, and we are also hosting the main events next week at the during the World Manufacturing Forum. So if you want to join the forum, you can do it also remotely. Feel free also to ask questions if you have at the end of this event. Thank you.
Thanks a lot, Marco. This is a huge project, and I guess you're very busy in this project. So thanks a lot. And now our next project is an LMS project, Cell D, and it will be presented by Kyriakos. At least I cannot hear you. I guess you're on mute. No, I don't know if the others can hear, but at least I cannot hear you yet.
Now I can.
Yes.
Now I can. But I'm not able to hear the speaker.
No. The Kyriakos, we cannot hear you. I guess you use earplugs. Can it be? Perhaps if you unplug them.
He has his microphone turned off. At least that's the symbol that shows on the screen.
Kyriakos, can you hear us at least?
Yeah.
Okay. I guess there was not something.
Okay. Can you hear me now?
Yes, perfectly. Super.
Okay. Sorry about that.
No issue.
My name is Kyriakos Ambatakakis. I'm part of the LMS technical team working on the ZELDI project. So ZELDI project runs its second part in 2022. Its consortium has gained one additional member, having 6 in total: LMS, Comau, Irida Labs, Interactive Fully Electric Vehicles, or IFEVs in short, CASP, and European Welding Federation, the new member, or EWF in short. So ZELDI, or Zero Defect Welding for E-Mobility, as the project name implies, aim on identifying quality issues which are concerning the joining of cell tabs for battery assembly applications, which are utilizing laser welding. So, considering that an electric vehicle battery pack consists of cells connected together, the quality and the performance of each individual connection or joint can have a significant effect on the overall operation of the battery pack and eventually of the electric vehicle. So identifying the electrical and mechanical quality of each individual joint in a battery assembler laser welding application without having directly to measuring it is the main problem issued and addressed in the ZELDI project for reducing the cost that may be induced in battery pack manufacturing from defective joints and provide the means for repairing and performing quality optimization for these joints. So how ZELDI resolved the previously mentioned problem and also make it compatible with current industrial needs. So ZELDI created an infrared vision edge system for quality inference with the following four main features. The first one is an off-axis setup, which ensures easy installation of an infrared camera without need coupling it with a laser optics. The second is a supervised machine learning schema which standardize the development of quality assurance model and enables also its rapid reconfiguration. The third one is that the actual quality assurance model has a very low data requirements, which is just based on only 3 infrared features for making the decision on the electrical and mechanical quality. And finally, a system that has an interface that enables real-time data visualization without having from the end user to install any software or other things in order to operate it. Concluding, the importance of ZELDI project is in a broader spectrum is considered to have a positive effect on strengthening, first of all, the position of EU battery assemblers and EU automotive companies, contribute to the cost reduction for e-mobility and welding applications in general, and of course introduce Industry 4.0 quality control practices into real production scenarios. So that's all from my side. Thank you, and of course thanks EIT Manufacturing for the opportunity for running this project and for their overall support during its lifespan.
Thanks a lot for the presentation. I'm sure that such a system can have huge benefits for the manufacturing sector in Europe. So thanks, Kyriakos. So the next project is Leaders Competition, and the presenter is my colleague Maggie from EIT Manufacturing.
Yes, hello Gerhard, hello to Vienna, and hello to everyone listening in today. My name is Maggie Vitiana Plaku, and I am here today in Brussels at the EIT Manufacturing Summit. And we actually just finished, I think, half an hour ago, the Leaders Competition. So I'm very excited to be here and to talk today about the Leaders Competition in a nutshell, and also a little bit about our winners and finalists. So just to start with the general information, what is the Leaders Women Innovators in Manufacturing at EIT RIS competition? So I think you can hear it from the name reveals a lot. So this call aims at identifying and supporting the best women innovators in EIT RIS eligible countries. So to everyone who is not so familiar with this term, EIT RIS eligible countries are countries which are, according to the European Innovation Scoreboard, either moderate or modest innovating countries in Europe. But for us, the important part here is that all of these women should have played a leading role in developing solutions addressing manufacturing related challenges with either strong environmental or societal impact. And besides of that, the purpose of this competition is to draw attention to women leaders in the field of manufacturing, because very often women are the hidden champions in our society. And with this competition, we wanted to put them into the spotlight and give them the attention they deserve, because they have invented great solutions to the benefit of our societies. So for this reason, we have provided to the 30 pre-selected candidates pitch trainings. These pitch trainings should support them in increasing the visibility of their projects and achievements, and also, of course, support them in attracting investors. But moreover, what we try to do with this activity, so we hope not only to support and highlight the identified women leaders in EIT RIS, but we also want to eventually motivate more female talents to innovate and lead, and therefore be the role models for the next generation of young women and girls. And personally, since I'm already here right now and I've seen the live pitching of our 6 finalists, I'm very proud to see how much great potential we have in the EIT RIS countries, and how many talented women innovators could be identified by this competition. So this is one part. The second part is how was this structured? The competition consisted of 2 selection rounds, and in the first selection round, they submitted just a written application, and for the second selection round, they had a video pitch. And the chosen 6 finalists had the opportunity to pitch live in front of the jury, and as I told you before today, we identified our 3 great winners. So please check out also our social media accounts and LinkedIn, and get in touch with them, and stay tuned also for the next round. Thank you very much.
Thank you, Maggie, for this super important initiative. It is clear that you are excited about being there, so I still wish you a nice day there in Brussels.
Thank you.
So the next project it will be presented from Jose, and the project is Cheap Rep Mac.
Thank you very much for the introduction. Well, I am Jose Manuel Martin from CIT, and I am the coordinator of the project Cheap Remac, with the stand for cheap recycling of neodymium iron boron magnets. So the problem that we are addressing is that at present, the European manufacturers of electric equipment have to import the neodymium iron boron magnets that they need for their equipment from China. China has a dominant position in this market because China is the only country that are in all the steps of the value chain, from the extraction of the raw materials in mines till the selling and commercialization of the magnets. So this dominant position in the markets has produced in the last 20 years several crises related with the instability of the price of the magnets, and as well with the supply of these magnets. So the solution that we propose in this project is to recycle end-of-life sintered neodymium iron boron magnets and use this scrap, neodymium iron boron scrap, as a substitute for their raw materials from Chinese origin. At present, as far as we know, there are no commercial activities in Europe related with the recycling of these materials. There are many research projects that are developing technologies for that, but there are no commercial activities. In particular, what we propose is what is called a direct metallurgical route for recycling. What is the advantage of this kind of road? Well, first, the recycling road, the recycling loop is very short. It's a very direct, with few steps of recycling. That means that the final product is going to be cheaper, should be cheaper. And what we try is to produce a new powder, a recycled powder that we can use to make bonded neodymium iron boron magnets. And these bonded magnets will have properties, mechanical and magnetic properties, similar to what you can obtain from primary resource. So this is important for the European society because, well, thanks to these recycling activities, we can the European manufacturer can reduce this supply risk that I have mentioned before. And likely, if we are able to carry out this recycling route in Europe, likely we'll be able to reduce the price of the magnets for an equivalent application by a factor between 3 and 6. On the other hand, at European level, we know that Europe imports every year about 30 kilotons of neodymium iron boron magnets. And this project may help to reduce these imports. We have estimated that in the last 5 years, in the next 5 years, we could provide by recycling between 0.5 and 1 ton per year. And this figure is going to increase after 2027, of course. So the main results that we have achieved in this project is first, a new process, a new road based on gas atomization to produce recycled powder from neodymium iron boron scrap. Second, two complementary technologies to process this powder, which are compression molding and injection molding. And these technologies allow us to make recycled magnets. And finally, information about the testing of real demonstrator made by these technologies into real applications. So the partnership, you can see on the screen the name of the partners that are collaborating with us in this project. And just I would like to mention the role of each partner. CIT is producing the recycled powder. Magneti is manufacturing the demonstrator. Fraunhofer is carrying out the characterization of the materials. Copresi is testing the demonstrator in 2 applications. Mondragon University is designing the electric motors of Copresi so they can work with these recycled magnets, and Grundfos is proposing an additional application. So finally, I want to thank to EIT Manufacturing for supporting this project and helping us to develop this recycling road. Thank you very much for your attention, and if you have any question, please don't hesitate to contact me.
Thank you, Jose. It's great to hear that we have such recycling initiatives here in Europe. So all the best for your project.
Thank you.
We have now one project more. It is the project Param, and it will be presented by Tiago. I just wanted to bring up again the point that if you have questions to some of the projects, of the presentations, then please put them into the chat. Okay, and now, Tiago, the floor is yours.
Okay, thank you. Hi, everyone. I'm Tiago Dutra, and I'm a researcher in the additive and manufacturing field here at INED, which is the Institute of Science and Innovation in Mechanical and Industrial Engineering. We are a research technology organization, and we are based in Porto, Portugal. And today I'm going to present you our project Param, which is being developed with our partners, CADFlow, which is also from Portugal, Morphica, and Prima Additiva that are from Italy. Okay. So, well, currently, we know that the tools of design for additive manufacturing, they're like process-driven. So it means that they are focused on optimize the 3D printing strategy for each case. And each part is kind of analyzed from scratch, as there is no knowledge transfer from case to case or even from among stakeholders. So besides to fully exploit the potential design benefits inherent to the additive manufacturing, such as topology optimization and part customization, which is required the availability of skilled designers and other technicians. So what is, let's say, our solution? So the idea behind Param project is to build libraries with, let's say, parameterized parts that are integrated in a design software platform widely used, let's say, at a global scale, which in our case is the Siemens NX. And all this integration is based on the development of APIs, application programming interface. So in addition to this design feature, the tool also contemplates, for example, an eco-score modeling, so an eco-score module. So the user will be able to verify, for example, the environmental impacts of the part that is going to be printed. This eco-score model derives from the life cycle assessment techniques that have been largely applied on previous INED projects. And let's say in terms of main outcomes, we can say that the tool will be able to allow, for example, untrained designers to exploit the full potential of the additive manufacturing technologies, and as well as to develop internal skills due to the self-learning approach when using the tool. And it also improves manufacturing flexibility and overall efficiency, considering, for example, cost, lead time, resource, all with the goal of zero waste in the material and the energy consumption. So at the end, we expect, for example, to have a design tool enriched with a database of applications of parametric and pre-engineered concepts that, in this case, are qualified to support the designers to develop their products, in using additively manufactured solutions. So at Param 1.0, and then I will explain why 1.0, we adopted two demonstration cases, a circular gripper and a rectangular gripper. Since this is like the first step for the tool, we adopted like up to 8 parameters, which we believe that is enough to define a gripper with a simple geometry. However, we know that it is very important to either expand this library, incorporating, for example, more parameterized parts from different AM process, and also adopting different materials, for example, including polymeric parts. And in addition, we also understand that it's necessary to include more complex parts. And by complex, we mean to say parts that require more than 8 parameters to be defined, as we are defining now. In terms of activities, InEdge is responsible for the development of this new software, and will lead all the creation of the design for additive manufacturing and X-Core model. CADflow, our Portuguese partner, assumes as acting as business owner, assumes the integration as an add-on in the Siemens NX. Prima is supporting us in the definition of the key parameters related to the manufacturing process, and Morphica assumes the development of the supply chain module. Well, in a few words, that's all from me. That's all that I would like to present to you. I would like to thank EIT for supporting us, and I would like to thank to each and every one of you from the audience today. And if you have any questions, I will be more than happy to answer it. Okay, so that's it. Thank you.
Thank you, Tiago, for giving us an update and insight in your project. So with that, actually, we are through all our projects for these breakout rooms. So if there are questions, but I just see that there are no questions, but there are 2 comments which I wanted to bring up. So one comment is about the GPREMAC project from Jose. There is the statement that it opens the big topic of public resourcing call in urban mining. And then
yes. Can you repeat the comment, please?
That it opens the big topic on public resourcing call in urban mining. So it is not a question, it is more a comment.
Yes, I see. Well, I agree. And I think that this kind of urban mining is going to grow in the coming years. The reality is that many of what we call critical raw materials are produced out of Europe by mining, but at the end of the day, they finish in electric equipment or other kind of equipment that is manufactured or is used, let's say, is used inside Europe. So finally, when the life finishes, they go to the landfill, and that means that you have in the landfills a lot of equipment where the concentration of these value elements is hundreds of times higher than in nature. So they are easier to recover than from nature, and more with less environmental impact. So yes, this is urban mining, in fact, and it's going to grow up in the near future.
Since you are now here, I have already another question for you. How do you engage people to contribute?
Sorry, for me?
Yes, yes.
Okay.
So how to engage companies, people to contribute?
The main, let's say, the main reason to promote the recovery of this kind of resource is economical. As I mentioned before, so you have to sell the recovery as first is less, the environmental impact is lower than mining for sure, but secondly is much more profitable because as I mentioned before, in the landfills you have the concentration of these value elements. The concentration is 100, at least 100, sometimes more times than in nature. That means that they are much easy to recover and to purify that you have to get them from ores in nature. So there is a very clear economic advantage. We are talking about elements like, well, in my case, basically rare earth elements, but we can be talking about things like gallium, niobium, cobalt, and other elements. So yes, basically the reason is, a main driver to involve companies on that is economically is profitable.
Okay, thank you. So we would have more questions, but unfortunately we are already running out of time. So thanks to all the speakers for their presentations. I hope that we will have many, many more of these kind of projects in future. Now at 1:30, the Teaching Factory competition will be on the stage. So I would say we close this session so that everybody is available to join the Teaching Factories. Thanks a lot to all of you for your contribution.
Thank you.